Well, good evening, everybody. Thank you for coming to LES's second public meeting on the IRP. I hope you can hear all right. My name is Scott Benson. I apologize. I got to do this through a mask. A lot of people's children bring home stray animals. Mine bring home COVID. I had one of them get COVID, very mild. Luckily, nobody else got it, but now I am running through the 10-day string of wearing a mask. So we're going to deal with that tonight, but it should be okay. If at some point you don't understand anything I said, this is good because it gives you an excuse. You can blame it on the mask, all right? So integrated resource plan, real quick show of hands. How many people have been to, we're at the first meeting, I guess. So a lot of folks, not everybody. So real quick, in a nutshell, when we do our integrated resource plan, which we do every 5 years, we're projecting out in the future, at least a couple of decades, trying to look for the right resource mix that's going to best serve LES and our customer owners. And that means at the lowest cost and at the highest reliability. And always a core piece of that is sustainability. So that's what we're working on tonight. At the first public meeting, we kind of set the stage for how the process was going to run, what goes into it. But now we start to get into the real meat. And a big piece of this has been looking at our sustainable energy program, those incentive programs that we offer to partner with our customers to do energy efficiency improvements at your homes or your businesses. We had a consultant come through that did some work on that. I'm going to hand off to Mark Skolnick. He's going to do a great job of taking you through all of that. So if you hadn't seen it before, that's okay, because he'll go back through the history a little bit through his presentation and show you some of the changes that are coming up. At that point, then he'll hand off to me, and we'll start talking about the next phase when we actually go through the studies and the models to decide what that resource mix look like going forward. Real quick safety briefing, all right? We've got fire extinguishers right out here in the hall, and there's one in the kitchen area. We've got an AED out in the hall. Do I have anybody who wants to volunteer to call 911 in case of an emergency? Shelly, you're back there. Shelly, what's the address here? Very good. Raise your hand if you know CPR, if you've been trained in that. Okay, quite a few hands around there, so if you have a problem, we've got that covered. Look around real quick, and I want everybody to look at the exits. Make sure you pick them out. You got one up here, you have the one in the back, right? If we have inclement weather tonight, I don't think we're going to have any storms, at least not during this, but if we do, we'll go out into the hall. There's some bathrooms out there. Just follow LES staff, all right? And with that, I will hand it off to Mark and we'll get started. Thank you.
Thank you, Scott, and good evening, everybody. It is really neat to see a big crowd at an IRP meeting. It really is. It makes me nervous, though, I got to tell you. The reason is amongst the audience, there are current board members, there are former board members, there are colleagues, there are retired colleagues. I have to stay factual because you will call me out if I don't. This is an engaged group, a group that really cares about the direction that we're all heading. And that is something that's really neat about public power is it is a conversation. It is a group activity. You own the utility as a ratepayer. And so that makes these opportunities really unique. Now, if you were at the first meeting, and it seems like it was eons ago, it's a couple months ago, we talked about the Sustainable Energy Program. And I want to make sure everybody is aware of what that is. The utility launched the Sustainable Energy Program in 2009 as an initiative to encourage and influence decisions among customers when they made energy efficient decisions, ranging from heat pumps and air conditioners to commercial lighting to systems that are put in industry. And it has been a program that has not been on cruise control. It has adapted through the years. We have brought in the heat pump water heater in the last 3 years. Why did we do that? Because a very wise individual sitting amongst us said, you need to consider heat pump water heaters. And we took a look at it and we said, this is a no-brainer. We need to incent this. And it is growing. It is relatively tested technology over years, but it's relatively new to Lincoln. And so it takes a lot of different individuals to make measures like this take off. You've got to have contractors that are comfortable promoting the technology to educate customers about what it can do. and then have that incentive. So that's just an example of how we have evolved the Sustainable Energy Program, which currently has $1.5 million budgeted. We've used not quite half, but approaching half of that this year. And we have incented almost $30 million since 2009 for tens of thousands of energy efficient qualifying projects. So what we do at the IRP time is we bring in a third party to look at our energy efficiency program and give us thoughts about what is considered best practices. Sorry for folks online, I was standing too far forward. Somebody should have just yanked me back. We have a third party come in and they are familiar with best practices. They are familiar with different inputs that we should consider putting into our model, because we look at these measures, we look at the incentives that we offer on a benefit cost basis to see if the benefits of energy efficiency incentives, the benefits typically being reduced need to purchase energy and reducing that peak demand and the value of that reduced peak demand and deferring generation, if those benefits outweigh the costs of doing the incentive program, which is the incentives and the administration and promotion, okay? And so we have a couple of benefit cost tests that we introduced to you last time, and we want to make sure that the inputs we put in to model that are still appropriate. So I'm going to have you recall what those inputs that the consultant suggested. Endfront Consulting came in, looked at our existing inputs. We're going to go through those very quickly. What those recommendations were, we ran the new inputs that we received through the consultant in the model. I'll show you how those turned out. And then also, if there's anything, any energy efficiency measure that we're missing, that we're not offering, let us know, consultant, let us know what we should consider, and then we will take a look at that and see what the feasibility is in this market. So one of the inputs that was in the consultant's report, or one of the recommendations, was that we need to reflect inflation and periodically update that. And so to be consistent in how we model generation and energy efficiency, we would use a 2% inflation rate. Now, I know that seems absurd when I'm talking about a 2% inflation rate on a day when it's probably 8%. Believe me, a year ago, we would have thought 8% was out of the, bonkers. But the Fed's long-term benchmark is 2%. And because this is a long-term planning model, that is the number that we put into the model. The consultant suggested that our forecasted retail rate escalation was a little low and that we might consider increasing. And so they had broken it out by residential and commercial. We have basically one input in our model for escalation of retail rates. So we essentially used 1.5%. We were using 1%. So we are going to reflect that if possible going into the future, we may see a little bit higher pressure on retail rates. How do we value reducing that peak demand? What's the value of the capacity, the generating capacity, if we free it up by promoting more efficient equipment that occurs on that hot summer afternoon? And we had used a $30 per kilowatt year, which is a value of capacity. And we had, but we had escalated it at a pretty aggressive rate. And as we discussed with the consultant, it became clear that the industry is actually valuing capacity based on the cost of overnight construction of generation. That's where the industry is going. And so we have followed suit, and we are reflecting that in our model, that we will use the net present value of overnight construction for a generator, and that values out to $59 per kilowatt year, and we will hold that value steady through the entire planning period. It just so happens that's about equivalent to what we were doing before at the $30 rate, but escalating it by 5%. So we're really not departing that value of capacity, but we are reflecting it in a way that the industry is moving towards. You might recall that we do account for the value of CO2 in our model. The recommendation was that we escalate the value at $20 a ton a little more aggressively than we were. So we were just escalating the $20 per ton by inflation, and the recommendation was to be a little more aggressive. And so we're escalating that $20 per ton at inflation plus 2%, so 4%. So that's in the model as well. So take all these inputs, you plug them into a model, and you come up with some results that tell you if the SEP is a cost-effective program. The required minimums, and this comes from the IRP we did in 2017, was that we want the benefits to be at least as equal to the cost, if not better. And on a second test, which is called the ratepayer impact measure test, that takes into account the fact that we lose revenue as energy sales decrease, but we still need to recover fixed costs for the infrastructure. So we would accept a 0.6, not a 1, but a 0.6. So if the program as a whole meets those or exceeds those two ratios, then it is cost effective. And before we had our consultant come in, this is where we were, 2.32, way above 1, and 0.71, which is above the minimum 0.60 ratio. After we put in all the new inputs, we actually improved the numbers a little bit, okay? So that means that our SEP, based on these new inputs that I just discussed, continues to be a cost-effective program based on the current incentives, based on the current programs. Now, the world around us is changing, so we're not just going to sit static with this. We're going to continue to monitor, but based on today's inputs and programs and incentives, it remains a cost-effective program. The one other piece I mentioned is that the consultant suggested we evaluate a few additional programs, including high efficiency dehumidifiers for residential, a variety of commercial kitchen equipment, and a couple of other, maybe not energy efficiency, but rate mechanisms like variable and critical peak pricing and voltage optimization and conservation in the distribution system. So we took what they recommended, put it in the model, and did some additional evaluation and research, and this is what we found. Residential dehumidifiers have a very slight reduction in kW to a base model and a relatively modest energy savings. The thing I really want to draw your attention to is 88%, according to Energy Star's 2020 market saturation, 88% of residential dehumidifiers are Energy Star rated. That market has tipped, right? So there is not a compelling need to provide an incentive when you're almost to 100% of the market. In fact, you would have difficulties finding a non-Energy Star residential dehumidifier. That's a good thing. That's become the new normal. And that's not just the case with residential dehumidifiers. There are other appliances where you cannot find a non-Energy Star option because the new normal is energy efficient. Now, we did find in the commercial kitchen area with the dishwashers, the combination oven, the steam cooker, that there was relatively decent demand savings and energy savings. These are incentives that they suggested. You can see the ratios. Certainly on the utility cost test, they perform very well. On the RIM test, they are below the 0.6 in a couple of cases. So we may want to fiddle around with the incentive levels and may very well offer these up in next year's program. There is some possibility. On the other hand, I do want to point out that we're not going to set the world on fire with commercial kitchen equipment. We're not going to bring an end to climate change because of this. But is it something that we ought to offer? Probably. We'll probably want to look at the incentive structure. You can see that the market's maturing though. It's approaching 50%, and that's considered pretty good. So there probably is a room for this. It's just not going to light the world on fire. Water heater load control was another measure that was recommended we look at. It has a projected 0.5 kilowatt per controlled water heater impact on peak, and it didn't perform extraordinarily well on the utility cost test or the ratepayer impact measure test. But if over time we're going to see more electric water heaters, it may be a good idea to get some experience and understanding of how these things operate. So we may consider doing a pilot in this area. We're still kind of combing some of this out, but I think it warrants further investigation to see where we might go with this and see in actuality if it really has benefit compared to the costs it would take to control the water heaters and provide incentives to customers and that type of thing. So long and short of it, the residential dehumidifier is kind of a dog. The rest of them warrant further evaluation. And that is the end of that. So I'll turn it over to Scott.
Okay, can you hear me okay? Even with the mask, that's good? All right. So I had to leave the room for a second, so somebody be honest with me. How'd Mark do? Good? All right. Very good. I heard him make his snide comment at the beginning about how we got such a good turnout for the IRP. Tomorrow he's going to tell me that's all because of him. Okay, so Mark told you about the Sustainable Energy Program. We kind of closed the door on looking at that piece, and now we start the next phase, which is really, to me, the most exciting one. And that's when we plan out what that future resource mix might look like. So what we're going to do tonight is kind of set the stage for how that study is scoped out, what goes into it, what we have to consider. And there's a reason for that. That's because at the August meeting, we're going to go through all of the details. We're going to talk about what the study showed us. We're going to talk about how that's going to inform and guide the plan that we have for meeting our decarbonization goal, which is net zero CO2 from our entire portfolio by 2040. And we're going to talk about our 5-year action plan, what comes out of this IRP that we're going to roll forward with. That's an hour-and-a-half meeting. And believe me, it takes a long time to go through all of that information and answer your questions. So the reason we're going through the scope tonight is because in August, we're going to go through it really quickly just to refresh and then dive right into the weeds. Okay, does that make sense? All right, so let's get started. So when we run these simulations, these models, it takes a really big software package. We run one that is called, in simple forms, a GIS. A GIS was developed by EPRI, actually back in the 80s is when it first started. It's been kind of spruced up a lot since then, but that was the first time. A lot of folks use a GIS. Probably one of the biggest ones is MISO. Now, MISO is the equivalent of SPP, the Southwest Power Pool. Everybody heard of SPP? Okay, MISO is basically SPP just to the east of us. If you're in Iowa, their SPP is MISO. Okay, MISO's put a lot of money into development of a GIS over the last few years. They do a lot of studies with it. Now, what a GIS does is what's called dynamic programming. So you say, here's my future load needs, and I want you to go through and tell me what the best resource mix is. And you give it a bunch of options to pick from. Dynamic programming means that it looks at literally every combination of all of those resources to identify the one that is the lowest cost on a net present value basis. And when it's doing that, it's taking into account capital construction costs, what it takes you to build it, the fixed and variable operations and maintenance costs, what it takes you to actually run it and keep it running in good shape. And most importantly, it's looking at reliability. Can that resource mix serve the load over the entire course of the year? Okay. So when we do that, we got to put together a big model. And it starts off really simple. We have two systems. We have LES, which is system A, and we have SPP, which is system B. Now, since the GIS is looking really long-term, lots of different options, it makes the transmission system very, very simple. It's literally one connection between LES and the rest of the world. That's how it models it, all right? So the first thing we do is we load in LES's latest forecast. for the load, 2022 load forecast. Every year, LES does a load forecast, projects out in the future 30 years. What's our load growth going to be, both from an energy standpoint, how much energy you consume throughout the year, and most importantly, peak demand, the energy or the power you're consuming in late afternoon, early evening in July and August. That 1 hour that determines everything we build to serve your load. We only hit that peak once every few years, but that's what we have to build to, okay? So we load that in. Next thing we do is we load in all of LES's existing resources. And you know what, I should tell you, because I always have people trying to write this down with notes. Maybe Mark mentioned it. All these slides will be available on les.com, les.com/IRP, probably tomorrow. Okay, so you can go out there, you'll have all the same information. And if you're really a glutton for punishment, you can watch the video and hear us talk again, all right? Okay, so we load in all the existing resources. So now AEGIS knows what our future load is and what our resource mix looks like. Now, I told you, what we're really looking at is what are all the new things we might add? So you got to find data for that. So actually, you know what? I skipped ahead. I'll skip one more. There's the new data, okay? You got to have data for that. Here's why that's important. How many people have ever seen news articles, magazine articles, any kind of things, most of them are online, that tells you about a new generating technology and maybe what it costs and how usually it's the best thing since sliced bread? How many people have seen those? Okay, everybody's seen that stuff. And those are really good articles. The problem is you can't compare one to another one that talks about a different technology because different assumptions. So what you want to do is try to find one source that ties everything together. The one we use, which is to you down the lower left-hand corner, that is from the U.S. Energy Information Administration, the EIA. They do a great job of looking at lots of new resource technologies and giving you an apples-to-apples comparison of the cost and the performance data. All this stuff's linked, so if you really want to dig into it, you can get the presentation tomorrow, go in there and you can see all the sources. Okay, the part that I skipped, which is very bad, is we got to load in the load and resources for the Southwest Power Pool, all right? You need to know what that is. So what we use is the Southwest Power Pool's latest planning model. Okay, this is from 2021, what they call their integrated transmission planning model, where they're doing similar to what we're doing. What's the future load look like? What do we think the resources are going to look like? So we're leveraging all of their assumptions. It's just a model. That means it's not perfect. It's far from it. But when you're in the Southwest Power Pool and you're using the Southwest Power Pool's latest model, that's the best thing out there. All right. So then you got to know fuel costs, both for us and SPP. So that is also information that's put out by the Energy Information Administration. Every year they do their annual energy outlook, and they're projecting fuel costs out in the future. And the ones we're looking at are coal, nuclear, and fuel oil, okay? So anybody who's still paying attention, and that's hard because Mark talked before me, coal, nuclear, and fuel. Guys, that was funny. Now, come on. Coal, nuclear, and fuel oil. What's the one I didn't say? Natural gas, right? So we don't use their assumptions for natural gas. And why is that? Far too volatile. Anybody watch natural gas over history? It goes up and down by a large margin. So what we do is we actually run all these scenarios across 10 natural gas prices, ranging from $1 per MMBTU to $10 per MMBTU. I will tell you right now, it looks like a pretty good range. If you go back in 2020, which is the low end for recent history, the average natural gas price across the year was $2.03. So a low end of $1, pretty good, right? It's probably maybe not going to get down to $1, but that's a good kind of low end buffer. In 2008, that's the highest in recent history. The average gas price for across the year was $8.86. So almost $9. That kind of is where we get $10. A lot of stuff in the news about high gas prices, right? Natural gas prices. I looked last week, year to date, the average was $6.01. I will tell you this year, unless things go really crazy, not going to make it to the 2008 high level mark. If you look at the trends, it was much higher then, okay? So we vary that because it moves around a lot. There's another thing that has a big play in this, and that is the regulated value of CO2. So we do the same thing we do with natural gas. We vary that over a range of prices from $0 per ton, which would be where we're at today, to $90 per ton, right? Now there's two important things here. One is that's a regulated value of CO2. That's a fancy way to say it doesn't just apply to our resources, it applies to everyone in the Southwest Power Pool, okay? It can represent a lot of things. It could be environmental regulations, could be things set up by the Southwest Power Pool. The simplest way to think about it, just to give you a frame of reference, is if the federal government instituted a carbon tax on CO2, that's a good frame of reference. Not the only thing it represents, but that's the easiest one to have in your mind as an example. All right. When we go from $0 to $90, that encompasses what today is the federal government's interim guidance for regulated value of CO2. They call it the social cost of greenhouse gases. They have 3 different estimates in there. And if you look at those, $0 to $90 basically encompasses all 3 of them, from the lowest to the highest. So that gives us a good range that we're looking at. All right. So we take all that and we dump it in the model. And Aegeus says, okay, I'm going to come up with the lowest cost and reliable resource mix for LES that takes into account sales to and purchases from the Southwest Power Pool market. Okay, it's a simplistic representation of the way we operate every single day. Now we're going to do that for the next 20 years. So we're going to look out from 2022 to 2041. And when Aegeus does that, it has a rule it has to meet, and that's that we have enough generation capacity to meet our peak load plus an extra 12%. That's a rule that comes down from the Southwest Power Pool, all right? So usually at this point, when we ever do these things in the past, the next thing I show you is what we call LES's load and capability chart. Again, we have fancy names for stuff, makes us feel special, but what it really means is what's LES's load forecast out in the future, and what is the capability of all of our existing generating assets? And you're really just stacking them up. If the load's here and I got more generation, I'm in good shape. If it's the other way around, I got to add something, all right? But we can't do that anymore. Now we actually have to stop and look at the Southwest Power Pool first, because what the Southwest Power Pool does and what their rules are dictate a lot of what we're going to do. Okay, how many people were at the IRP workshop last month in May, which covered the Southwest Power Pool? So I got, okay, 5 or 6. Shelly, I lied to you. I think I told Shelly that maybe there was 3. Okay, there was twice as many. I missed. So we're going to go through some of what we covered at that workshop. We're going to hit the high points for those of you that couldn't make it, so it makes sense what we're talking about here. We also have another workshop that comes up next month, July 21st, where we're going to get further into some of the details of the SPP rules. We're also going to cover the high points of those tonight in case you can't come to that next workshop. Okay, I'm going to tell you, I don't know what exciting things you have to do on July 21st, but even though you're here tonight, you want to come to that workshop, all right? I'll give you a little plug. It's going to be pretty cool. We kind of go through how those rules work for SPP, and then we're going to set you up with your own computer model, and you get to play the role of LES and develop your resource mix of the future and see how it works within those rules. Okay, so let's start talking about SPP. So I told you, we use SPP's latest model and we come up with what their resource mix looks like. So SPP puts out a 10-year model. In that 10 years, they have a resource mix for 2023, 2026, and 2031. Okay, and then in between that, you just interpolate in between. What we had to do is we wanted a 20-year resource mix, and they didn't have one. So we applied their logic they used in developing the first 10 years, and that's how we came up with year 20. So what's that mean? Well, it means we use SPP's assumptions, and that is all coal retires at age 52. Okay, regardless of its proximity in life, how it's doing, retires at age 52. Natural gas units retire at age 48. Then they looked at wind and solar, and they said, well, based on what we've seen in the past, what we think might happen in the future, we're going to project that we're going to go from about 0 gigawatts of solar to 25 gigawatts. A gigawatt is 1,000 megawatts. A megawatt represents about 250 average Lincoln homes, so it's a lot of power. Wind is going to go from today about 30 gigawatts to about 50 gigawatts, 55. So big growth there. What drives that? Well, when SPP did their model, they have what they call 2 futures, 2 different cases they model. We use the more aggressive one, the emerging technologies future. That means a lot more renewables, a lot more electric vehicles, a lot more electrification on the load side. All that goes into it. So that's the future we've selected. So you end up with this resource mix. Now, on battery storage, what they said is we're going to assume that 35% of what's installed in solar will be installed with batteries. Kind of arbitrary, but you have to have some rule of thumb. So we carried all that out to end up with the stack you see on 2041. A lot different than what you look at today, right? But that's our best guess through the Southwest Power Pool what that resource mix is going to look like. Now you lay on top of that line, that's what they say their peak load is going to be. What's the first thing you notice? The line's rather flat, right? And I just told you we ran basically an emerging technologies that includes electrification, right? So you did not expect to see that flat of a line. There's a reason for that. A lot of people will tell you that with electrification, we're definitely going to see load growth, more energy, but the peak, the load we have to serve in the late afternoon and early evening in July and August in this part of the country, probably not going to go up as much. Okay, raise your hands, and I promise not to hold this against you. How many people got gas heat in their house? All right, get out. That's all right. Okay, so hold your hands up if you have gas heat. Keep your hands up if you have electric air conditioning. Everybody's got electric air conditioning, right? Outside of you having an electric vehicle, what's the biggest load in your house from our standpoint? The air conditioner, okay? So when we talk about getting most people on electricity, where do you think the biggest change happens? In the summer, where you already have an electric air conditioner, or in the winter, where you're talking about adding what? Electric heat, electric water heating, right? So a lot of that, what you see is the peak load may not go up that much, but the load outside the peak periods in the fall and spring, especially the winter, that's where we probably see more load growth, okay? So that's what they've got modeled here. A lot more energy consumption, but the peak doesn't go up that much. The other thing you should look at right here and say that it doesn't make any sense is I told you the Southwest Power Pool requires all of us to bring enough generation in the market to meet our peak load plus an extra 12%. You tell me, does that look like SPP has an extra 12%? They got double what they need, right? Over double what they need. So you look at that and you say, well, why is that? That seems like it's way too much. So we got to talk through that. So when you look at capacity in SPP, everywhere, there's two different ways to look at it. One is a nameplate rating. The nameplate rating is what the maximum is available to put out if you put all the fuel to it, or if it's wind turbine, you got the wind blowing really fast, okay? It's no different than if you turn over your laptop at home, it's got a nameplate on it. It tells you how much power it consumes. Generator's got nameplates, tells you how much power it can put out, all right? Then you have the accredited capacity. That is the amount or the rating that SPP gives you credit for being able to serve at the time of the peak load. That is what goes towards meeting your peak load plus 12%, not the nameplate, what it's capable of doing, but what it's accredited or they can count on it doing at the time of the peak. Now, if you have fossil resources, okay, natural gas, coal, nuclear, the way they determine that accredited rating is you have to be able to do that for 4 hours straight. And every year annually, you got to run and you have to prove it. You got to do it in the summer because the summer is what matters around here because that's our peak load. So you got to have a really hot day and you show them, keep records that, hey, I did this for 4 hours. You can count that. For the most part, with fossil resources, your accredited capacity and your nameplate capacity usually pretty close to the same, all right? Because it's a dispatchable unit. You put enough fuel into it, you can typically get that power output. That's what it was built to do. You look at non-dispatchable resources, things we don't control, Mother Nature controls, wind and solar, and included in that, although not as straightforward when you think about it, batteries, okay? People always say, why is battery considered non-dispatchable? Because you can control it. You can decide when to discharge it, and that is right. The reason it's considered non-dispatchable is you can only do that for a short duration, at least today. So the Southwest Power Pool has a different way to accredit those, and it actually starts next year. It's brand new. This time next year, we'll be in the middle of it. That's going to be the topic of the workshop in July when we get to play around with the little model. And it's called Effective Load Carrying Capability, or ELCC. You're going to hear a lot about this throughout the IRP. ELCC basically says, how much incremental load can I reliably serve? Because I added an incremental generator, okay? And inherently, it typically goes down. The more you add of a certain type of resource, the less you get a count at the time of your peak. Now, that is not intuitively obvious, all right? I will tell you, as a general rule, if you add generation, I don't care what it is, any kind of generation, the reliability of the system only goes one way, up. It gets better because it put more tools in your toolbox. But it has diminishing returns. And a great example is we're going to think about solar in California. How many people know anything about solar in California? They got a lot of solar in California, right? The first solar that went in California was the best thing since sliced bread, because it was generating power without fuel from the sun, no CO2 emissions, pretty close to the time of their peak. It was in the afternoon. This was great. And then they added more and more of it, more and more of it. They added so much more that, you know what? They don't have peaks in the afternoon anymore. They move their peak into the evening when the sun goes down and all the solar shuts off. And that is now the critical time they have to meet their needs. Their biggest concerns are after the sun goes down, which is not the way it used to be historically. So you think about it. If you were the first person to add solar in California, it was the greatest thing ever. If you add solar today, they say, well, that's great, but you're really only generating at the same time all the other solar is generating. That's the point of ELCC, diminishing returns if you add more and more of the same thing. Still helps, it just doesn't help as much as it used to. Does that make sense? So I got 3 curves up here for you, and this came from SPP's first white papers when they looked at all these things. The one on top, the blue, that is the ELCC for battery storage, okay? If you can't make it out, what's across the bottom on the horizontal x-axis, that is the amount of that generation in the SPP footprint. Up on the vertical, on the y-axis, that's the percentage of the nameplate that you get to accredit. If you look at battery, it starts up at 100%, but then it starts to nosedive down, okay? The yellow line, that's solar. Solar starts out really good, then comes down, and the green line, that's wind. And you notice the green line, it starts way off to the right already, right? Why is that? Because we already got that much wind in the footprint. SPP has a lot of wind. So you can see that those lines are coming down the further you go. So let me tell you real quick, in a nutshell, because this is really complicated when they do these studies, how that works. So the first thing, we're going to use wind as an example. First thing they do is they say, okay, we're going to take all the wind out of the SPP footprint. We pretend it's not there. And we figure out how much load can we reliably serve with all the other resources. Then they do a study, same exact study, but the only thing they change is they put all the wind back in the equation. They say, how much extra load can we reliably serve since we added all the wind? And then very simply, if you divide the incremental load you can now serve by the amount of wind you added, the incremental generation you added, that percentage, that's the ELCC. That is the percent that all of that wind in aggregate gets to count towards meeting the peak load that people like us can use towards that requirement to have enough generation to serve their peak load plus 12%. Okay? They did that for one point in time. What they do is they do it for a whole slew of wind generation levels, and doing that calculation over and over, they can draw a curve. The percent you can accredit versus the amount of wind in the SPP footprint. Well, that's great. So that tells you for any amount of wind, what can all the wind count towards that requirement to meet the peak load plus 12%. But you got to break it down by individual resource because there's a lot of wind in all that number. So the first thing they do is they say we're going to prioritize that. There's 3 tiers. The first is tier 1. Any wind that has firm transmission to load, that means you say, hey, I'm LES, I got a load in Lincoln, I built wind in Oklahoma. Southwest Power Pool, I would like transmission service that you're going to guarantee me so I can flow that power between Oklahoma and Lincoln. And they say, no problem, but we're going to figure out what you have to spend to upgrade the system, and then you have to pay those dollars. LES does that all the time when we add our resources. So that allows us to be in tier 1. But tier 1 is limited to 35% of your average peak load over the last 3 years. All right. And that's a limit on the nameplate of the wind, not what you get to accredit. Any wind that you have that's above 35% of your average peak load that has firm transmission goes into tier 2. And then tier 3, that's wind with no firm transmission. People ask me all the time, why wouldn't somebody get firm transmission? Well, to us, we wouldn't do that because we have load we're going to serve. But if you were, let's say, Walmart, and Walmart has wind in the Southwest Power Pool, well, they don't have a load area like LES to serve, so they may not worry about getting firm transmission. All right. That's how they prioritize those things. Now, when I said tier 1 wind, that's limited to 35% of your average peak load. Solar is very similar construct, but solar is limited to 20% of your average peak load. Battery storage right now, there is no tier 1 limit, but those discussions are going on at the Southwest Power Pool today. I would bet you just about anything there'll be a limit at some point, but our IRP right now is based on no limit because there isn't one, but I think there's going to be one to come. And then they've got the buckets, tier 1, tier 2, tier 3. The way they differentiate in those, they say, okay, now we got a piece of the pie for tier 1. We're going to look at everybody's tier 1 resources, and we'll see at how well your load or how well your wind historically does matching up to your load. And if you do better, you get a little relatively bigger piece of the pie. If you do worse, relatively smaller. All right. That probably made no sense to you. That is the #1 sales pitch right there for why you should come to the workshop in July. Okay. The anti to that, why you wouldn't come, is I'm the one doing the thing in July. All right. Okay. So why we just go through all that? Well, because in order for LES to know how much credit we get for our wind, we have to know how much wind there is in the Southwest Power Pool. We have to know what the ELCC is for that wind so we can try to guesstimate what we're going to get for credit. So LES worked with a consultant prior to starting the meat of the IRP. There's only about 2 consultants out there that really do these ELCC studies. We worked with one of them and made projections based on that SPP resource mix I showed you a few minutes ago. This is what it looks like. The purple at the top, that's storage. Okay, the top line, that is tier 1 storage. Storage with firm transmission to load. You paid the upgrades to make it deliverable. The line just below it, that's a little lighter shade purple, that's tier 2, no firm transmission. All right. And usually when people see this, they say, well, but you showed us SPP's initial curve for storage and it went flat and then it really nosedived and yours is mostly just flat. You know why that is? Because if you look at SPP's curve where they predicted in their white paper, so it's not the same study, but they said it'd be flat and then it would nosedive, about 10 gigawatts. Our model, SPP's latest model, has 8 to 9 gigawatts in 2041. So it hasn't quite hit the knee in the curve where it starts to come down. All right. In the middle, that's solar. And gosh, you know what? That yellow is hard to see even here up front, so you might have a hard time making it out. But if you look at solar, it starts off at 72%, and tier 1 at 2041 is out at 57%. That's pretty good. You put in 100 megawatts of solar and you're going to count 57 megawatts of credit towards meeting your peak load. But you can't make it out. I can't even make it out up here. Tier 2 and tier 3, they're down around the 15 to 10% out in 2041. The bottom line, that's wind. And the first thing I'm going to show you is tier 2 and tier 3. Those are the light blue lines. See how they're pretty much flat at 10% all the way across. Look at tier 1. It starts at 19% and it ends up at 28%. What did I tell you before about ELCC? What direction does it go over time? Down, right? See, I lie to you all the time. That's not right. So why is that? Well, when you're testing this, remember, you're running a study with all the resources in the SPP footprint except for the one you're looking at. And then you add it back in and you kind of look what the delta is. What that means is all of the resources have an impact on the one you're studying. These aren't done in a vacuum. The reason you see that wind go up, wind is benefiting from solar's loss. So we talked about solar. The reason solar goes down is because as you add more and more solar, you're moving SPP's peak load out into the evening hours when the sun goes down, right? Well, when you move the peak load out into the evening hours when the sun is down, you know what? Generally, the wind blows more at that time of day than it did in the afternoon. So it didn't work well for solar because you move the peak out later, and that's why solar's line goes down. But because solar's line goes down and you move the peak out later, the wind actually gets more valuable and goes up a little bit. So there are some inner effects on that, okay? The important thing to remember is that's the percent you get to count. So if we put in 100 megawatts of wind in 2041, SPP is going to let us count that as 28 megawatts towards meeting our peak load plus 12%. That's one of the biggest rules we have to work through when we're doing something like the IRP. That all makes sense to everybody. Okay, so we did all that just so we could figure out what LES's resource mix looks like compared to our load. Roundabout way to get there. So the line, that is LES's peak load plus 12%, 2022 to 2041. The orange is the accredited capacity for all of LES's resources, not the nameplate, but SPP will give us credit for. So those ELCC numbers I told you about, we factored those in right here. And if you're paying attention right now, you're going, this is going to be the most boring IRP ever. Because do we ever need generation? We always have more generation than the load. It gets really close at the end in 2041, but we have enough. So where's the work come in? Here's where the work comes in. As we're running a GIS and we're looking at when we should add resources, you know, we're also looking at when should we retire resources, specifically our coal resources. What you're doing is you're adjusting natural gas prices and you're adjusting the regulated value of CO2. And you're seeing when either one of those or the duo in combination puts market pressure on your coal resource where it's no longer viable. And that is the point at which you say, you know what, I'm going to model that as a retirement. And then we're going to see what a GIS does to backfill that resource need. That's what we're going to bring you in August. Marilyn's excited. Okay. Any questions on that somewhat technical content? And remember, when we get to August, we're going to blow through this really quick in like just a couple minutes because we're going to have a lot of work to do going through the results because it gets kind of hairy. It takes some time. Yes, ma'am. We've been in the Southwest Power Pool since 2009. Their current market started in 2014, so that's what kind of dictates how we do all this. In 2009, in real simple form, when we joined SPP, you still kind of ran your own resources. We decided when to start them, when to stop them. They would help you decide once they're on where they should be dispatched to. In 2014, that changed. We handed them the keys. They tell us when to start our resources, when to stop them, what level to put them at. We just follow their orders. Yeah, Ken. Good question. Ken's point was, we talked about the resource mix in the Southwest Power Pool, right? LES has a goal to have net zero CO2 emissions by 2040. So you would think there'd be not many fossil resources in there, right? Okay, so here's the dichotomy. Remember, this is the Southwest Power Pool's resource mix. LES has a decarbonization goal. That's for 2040. I will tell you, LES's net zero CO2 by 2040 is one of the most aggressive goals by utility in the entire country. There aren't many people in that SPP stack right there that have a goal that's looking towards 2040. Now, you can see it's trending in the same direction, right? I mean, the coal is pretty low, right? Now there's quite a bit of gas. The thing you have to remember is when you get out there in models like this, this is showing you how much gas is there, how much steel and concrete is in the ground. It's not telling you how much that gas runs. A lot of folks, when they do modeling out into the future for things like net zero, what they'll tell you is, you know what, there's still going to be natural gas for a rainy day. It just won't run almost any time during the year, except the days you really need it because the wrong confluence events happens. You don't have wind, you don't have solar, the batteries won't handle it, whatever it is. So that's why you see this is SPP's resource mix, not our resource mix. So we have, what we do is Ken asked, do we have a similar one for LES? So when we start the modeling, which is where we're at now, we use LES's current mix. About 30% coal, 35% natural gas, 34% renewables on a nameplate basis. What we're going to come to you with in August is what our resource mix will look like in 2041 across 100 very different future scenarios. The point of that is, why do we model 100 different scenarios? I have no idea what the future holds. No idea. However, I'm highly confident that the future is in one of those 100 boxes. I don't know which one, but it's in one of them. What we're looking for is the resource mix that does the best over the majority of those 100 futures. You're gambling, right? I have no idea which is going to work out the best, but I want the one that gives me the best chance of being right over the widest range of future possibilities. Anybody else? Yes. Yeah, good question, Fuel. Phil. So Phil asked about the top box says 4-hour battery. So everything that the Southwest Power Pool modeled is 4-hour battery storage. Lithium ion battery storage. So why only 4 hours? The bulk of all lithium ion out there is 4 hours in duration. It is not a technical limitation. When you add lithium ion batteries, same kind of battery you got in your phone, same kind of battery you got in your electric vehicle, every time you double the time duration it can cover, you double the price. You could make a lithium ion battery that would do 8 hours, 16 hours. It's just cost prohibitive, at least today. So everything you see out there is 4 hours. So everything they modeled is a 4-hour battery. Obviously, we do an IRP every 5 years. Maybe in 5 years, you're not modeling 4-hour batteries because maybe there are 8-hour batteries. You're hoping there are day-long batteries. You'd like to see week-long batteries, even month-long batteries, but today we don't have them. So everything is 4-hour. Good question. Yes, ma'am, right here. Yeah, that is a good question. So the question was, I'll summarize. If LES has a lot of customers adopt electric vehicles, which is a really cool thing, are we going to be able to handle that, right? So I don't know if you're aware, LES did a study over 2019 to 2021, kind of a groundbreaking thing in this part of the country, where we partnered with, starting off, about 100 of our customers. At the time, it was about a third of all the electric vehicle owning customers in Lincoln were in our study. That little module they plugged into their car, it was like having an electric meter in their car. We knew every time they charged that vehicle, how much energy they consumed. It was GPS enabled, so we knew where they charged that vehicle. We knew every time they drove it, how many miles they put on it, how much energy they consumed. We did not know where they drove it. The GPS only worked when they were charging. We did all that to get a feel for what the load increment might be when you add these vehicles. When we found out, it's really big, like really big. When you add these things, you're talking about adding the equivalent of a large piece of a house every time you add an electric vehicle. What we also found out, there is a lot of inherent diversity in when people charge these things. Most people are only charging them every few days. When we looked at it across the bulk of the day, especially the peak we look at, typically you don't have more than 15% of those drivers charging at the same time. Just because they're out doing things at different times or they don't charge every day. I tell folks all the time, so my wife drives an electric vehicle. I love to say I own one, but I really don't. My wife drives it. It's a Mustang Mach-E. It's got a large battery. She's driving here around Lincoln, not that big a town. In the winter, she charges it once a week. This time of year, she charges it once every 2 weeks. Literally once every 2 weeks. So you have a bunch of people doing that, and all of a sudden, it's not as much load as you would think it was. But it does make an impact, and it does make our job harder. Every time the load goes up, that's more resources we have to have, right? And hey, you'd love to do as much you can with renewables, but they can only take you so far. So that would mean what? What's the easy answer? Some more fossil fuel resources, but now your CO2 emissions come along, and we have to balance all that with the decarbonization goal, right? So it does make a difference, and it does make it harder, even though we love it when people drive electric vehicles. Yes, sir, back there in the back. Okay, so the question was, you probably all heard it because he's there in the back, that these are just basically the generation, nothing to do with the cost. That is correct. This is the Southwest Power Pool going through and saying, what do we think our resource mix is going to look like out in 2041? When we run our model, that's where the cost comes in, because the model is going to look at LES's lowest cost option. Yes, sir. So the question was, when you do these kind of things, how's that factor in, and how did we handle the high loads we saw in February of 2021, the polar vortex, and most importantly, the high gas prices, correct? You know, a lot of that goes into how you build things. In this part of the country, and LES isn't alone, when we build natural gas generation, most all of it is what you call dual fuel. It has the ability to run on natural gas, which is what it does almost all the time. But sitting on your property are storage tanks where you have fuel oil, basically diesel fuel, and they can also run on that. And so during the polar vortex, most all of LES's natural gas was running on fuel oil. Normally, that would be crazy because it costs way more than natural gas, but in February of 2021, that was not the case. And so why did LES not have cost increases? Because we actually came out on the good end financially, because our resources continued to support the Southwest Power Pool at their time of need. Why did the Southwest Power Pool have problems? Well, you got to remember, here in Nebraska and north of us, February 2021 was really cold, right? But if you've lived in Nebraska for any amount of time, it wasn't like you've never seen that before, right? It's been cold like that before. We plan for those things. South of us, Oklahoma, Texas, unheard of cold, right? That's why they don't have the dual fuel. That's why they didn't at the time. So you have to factor those things in when you're looking at these things. Now, obviously, when we're running our models out, something like the polar vortex is not something we normally model because that is definitely extreme. But when we're putting the resources in, we make sure we have the reliability to continue to serve the load regardless of the conditions. Good question. Marilyn, I know you've been raising your hand. Correct. So Marilyn pointed out that it's pretty neat that wind and solar kind of help each other out, right? They're kind of a little bit interdependent. So when the solar is in there, you're actually getting more credit for the wind, right? And that's been known for a long time, right? That, hey, the wind, that blows really well in the shoulder months, really well at night. Man, the one problem with wind, it just doesn't blow typically in the summer when we have the hottest days during the afternoon. What's the thing you can count on with solar? Man, on the hot summer days in the afternoon, it will be there for you. But what's the knock on solar? But when the sun goes down, it goes away, right? They've always, since the beginning of time, complement each other pretty well. And so when you do this ELCC calculation, why is the whole point of doing that? Because it allows you to factor in things like that in your analysis. So that's why those percentages are important, because they account for all those things. Did anybody else have their hand up? Tim. How long can we run on fuel oil? You know what? That's a great question. That is such a good question. I wish I looked that up before tonight. Jason, you probably know off the top of your head. Okay, so what Jason just said is between 36 and 48 hours, which is good. Jason was more honest than I was, because I was just going to go right to 48. That's the number I had in my head, but Jason was honest. All right. Somebody else had their hand up. Oh, hang on. I got an online question. Yes. Okay, online question. Any thought on pumped hydro? Pumped hydro means that you've got a reservoir, think of any dam you've ever seen, and it's down here, and you have a great big basin up here. And at night, typically you would pump water up there so that during the day you could let the water go and generate electricity, all right? Pumped hydro, really great storage resource. One of the best ones out there. And why? Because it can be humongous, right? The scale can be big. It's got two problems. One is it takes a long time to get it done by the time you permit it and everything. And the biggest one is it costs a lot of dollars. Pumped hydro costs so much today that you cannot justify it. You can't come close, okay? Now, if you take and you look at different markets that you might see in the future, different aggressive futures, then it might be cost effective. The problem is you got to gamble a lot of money in order to get there. That is the one catch with pumped hydro. So we've looked at pumped hydro before. In this particular study, pumped hydro, I will just tell you up front, that's not one of the options. The EIA does not have pumped hydro in there, but we study the battery storage. It gets modeled the same, but we don't have pumped hydro in as an option. Okay, yes, sir. Okay, so the question was basically how we factor in carbon and how much pressure we're putting on decarbonization, right? So that was the part we talked about in the model where every time we run these cases, we're varying it from $0 per ton to $90 per ton. That's tons emitted by a fossil resource, all right? $90 per ton, very, very aggressive at the very high end of what the government shows for all of their projections of what it could possibly be. That's what's representing that value of CO2. As you turn up the price on carbon, it puts more and more pressure on removing the CO2 from your resource mix. That's how we model that. Yes. So the question is, does it factor in, because it's only the government that's creating that dollar amount, right? It's a dollar amount that is developed to try to reduce carbon emissions. 100% that's factored in. That is definitely factored in, because remember, we're trying to find the resource mix that works the best over the largest possible range of futures. And one of the very possible range of futures is that there's some kind of regulated value on CO2. Now remember, it doesn't have to be a carbon tax. That could represent future EPA regulations that put pressure on the units from a CO2 standpoint. So there's a lot of different ways that can manifest. We just use this as a proxy to say, as environmental pressure from a financial standpoint turns up, what's that do to the optimal cost of our resources? Okay, Anybody else? Yes, Ken. Okay, so Ken's question, good question, was the load that's up here, is that pretty much historically where the utility's hands off and the customers make their load and you just serve it? Or is there more baked in here to try to help customers use our product more wisely, which lessens the burden on us to serve it? And the answer is the latter. When I said we used SPP's aggressive emerging technologies future, they had a lot more energy efficiency in their model. They had a lot more demand response in their model. One of the reasons you see the peak in the summer not go up so much is because they're counting on those things to counteract it to some extent. There are other models, they don't call it this, but you would typically call it like a business as usual. If you took today and you just pretend in 2041, it looks like today. We did not use that one. We use the emerging technologies model because we think it's much more representative of what 2041 is going to look like. Okay, did I miss it? Kurt, yes. So Kurt talked about the chilled water storage that both the District Energy Corporation and UNL have used very successfully. So that basically in the nighttime hours, to keep it simple, when you maybe don't have to run as much of your cooling system because the temperatures are low in the summer, you chill water so that the next afternoon you can not run your cooling system as hard and use that chilled water that was pre-chilled to keep it down. And what's LES doing to promote that, right? Okay, so you mentioned two entities, District Energy Corporation, right? Of which LES is the managing partner, basically the administrator of that. So everything the DEC does, that's LES staff with their DEC hat on doing that and promoting that. And then UNL, they actually did the program through a partnership called NU Corp, which, who do you think's a partner to that? LES, right? So LES has actually been involved in all of those programs. The catch with those is they are a little bit cost prohibitive up front. They'll pay off if you have enough time. It's often hard to convince private business to wait that long for the payback. If you're the DEC or you're UNL, somebody who's probably going to be around for a long time, it's a little bit easier to have a longer payback. So the question was, what about the public schools? And it was, do we partner with them? Okay, so you guys, this is like handing me softballs. Thank you very much. Lincoln Public Schools. Lincoln Public Schools is almost 100% geothermal. Geothermal heating and cooling, using the temperature of the ground to provide their heating and cooling. And do you know what entity in Lincoln back in the 90s got Lincoln Public Schools started on that? I'll give you one guess. LES. And you know why? Well, okay, Kurt might have came up with the idea, but where did Kurt turn? LES had a big role in that. How do I know that? That was like the first project I worked on at LES. And besides that, it was still successful, okay? It's a large part of it. They've had some really successful reductions with that compared to other schools that were built historically different ways. So much so that you've seen in the paper, they've been retrofitting old schools. It's worked really, really well. That's another one that's kind of hard to sometimes justify up front. It's got a long payback, but LPS, they're going to be around a long time. Okay, I'll answer more questions when you're done, but real quick, I want to hop to the last slide, which is going to take me a second here because Ken had me rewind. Okay. If anybody's been to an IRP meeting before, you've seen this. This is our schedule for the entire thing. Run it up here. I don't know if the shading went. No, the shading went. Let's go back. Okay, you can't tell that, but it's shaded through June where we're at today. So all that's behind us. All right. We worked with a couple of consultants, did some studies. I mentioned one tonight. Mark talked about the other one. We took those results, rolled them in. We've had 2 public meetings. We did a workshop. I already mentioned to you in July, we've got the workshop where you can sit down with a hands-on model and play with your LES resource mix of the future, see how it meets SPP's requirements. We're doing all this so that in August, we can come to first LES board and a week later, a public meeting where we go through, remember, all the results of the analysis, how that will inform the decarbonization goal going forward, what we think the plan is for achieving that, at least as of today, and the action plan of the IRP, which always looks out 5 years in the future. You do an IRP every 5 years, so every 5 years you come up with a new plan for the next 5 years. Okay, that's all going to be coming up in August. In the meantime, we're working at finishing up, running that modeling, and working on the big report. Anybody in the room that's ever done a Word document of more than like 15 pages, they share our stress, right? Because it just doesn't work that well. So we're working on that right now. All this is heading towards having that report approved by the LES board in October, so we can get it turned into the Western Area Power Administration, our hydroelectric provider who requires us to do an IRP every 5 years, in November when it's due. In between August, when the draft is done, in October, when the final is approved by our board, hopefully, that is when we have the public meeting in August, and then we have 2 months to turn it around, where instead of me having an event and you get to come and talk, you tell me if you want to talk. You can call me, you can email me, you can come in and meet with me, you can bring friends to come meet with me, and the coolest thing is, you can let us know, and I will come out and talk to you. I'll come out and talk to you by yourself. If you got a group of friends, if you have a group who's like-minded, we love that the best. I'll come out and talk to your organization, all right? If you're really crazy, I'll bring Mark with me, all right? We'll both come. That's what we're doing in that 2-month period, is getting your feedback on the draft plan. When the plan comes out in August, it means the entire report, at least everything we can put together that has been done by then, okay? So you get to see the whole thing. All right. Any more questions for Mark or I? Shelley, do you have a question? Oh, sure. It's not on there. So the July public meeting, or the July workshop, sorry, and the August public meeting are at the LES Operations Center, our new building out on the southeast part of town, 9445 Rokeby Road, okay? That's where the first public meeting was. And what we did for folks at that one, if you came to the public meeting and you never seen the building before, we'll give you a quick tour afterwards. So anybody who hasn't been there, if you can come to that public meeting in August or the workshop, we'll take a few minutes and run you around. It's kind of a neat building. There's some neat things there. Anybody else? Okay, thank you very much. We're really happy when you come out. This public feedback is really good for us. It helps us know what the customers are thinking. Mark and I are both going to be around tonight. So if you want to talk to us afterwards, one-on-one, be my guest. Thank you very much. I hope to see you in July and especially in August. Thanks.